Let's talk about the difference between salt water that freezes into ice and fresh water that freezes into ice. I have here some fresh water, kind of smooth. It's got lots of clear parts to it, so it's a good clear ice with some white in it. And then the salt water I labeled with an S. You take it out. Already looks like there's water still in there. That's interesting. These have been in the freezer overnight. And there's water dripping a little bit out of it. Okay, but look how it's definitely much less clear. It's much more opaque. As I just check them out, the freshwater ice is solid, regular ice. This one is a lot softer. It's a lot smoother. Well, not smoother. It's a lot softer and easier to chisel away at. We're gonna put some food coloring on each one. So here's our regular ice. Just smooth, just food coloring. And on our saltwater ice, we'll do, whoa, look at that. As you look closer at the saltwater ice, you can see that there's a lot of little holes in it. That's why it's so easy to chisel away. That's why it's so easy to break, because it has all those little holes in it. And here, the freshwater is much harder ice. It's harder to chisel away, and it's just smooth on top. The food coloring is just sliding around instead of going inside those little pores. So let's talk a little bit about why that is. First of all, I'm going to show you, this is the saltwater container. When this dries, this is what it looks like. Do you see all this crusted, dried up salt? The reason this happens is that when ocean water freezes to form ice, it doesn't actually freeze the salt. Fresh water, you have your water, and when it turns into ice, you have this crystalline structure, your H2O, your 2 hydrogens per oxygen, and it forms this lattice structure. Over here with salt water, you've got your water, your H2O, and it's got bits of salt in it. When it freezes into ice, just the water freezes into ice. The salt does not freeze into ice. It is excluded and pushed out of the ice. And that leaves little pockets of this brine, which is a really stronger salt concentration of water. So it leaves pockets of brine. And that is what these little holes are from. Those are where the pockets of brine are. And that's what that liquid left behind is. If you were to taste it, it's extremely salty water. It is that very salty brine that was not frozen. And I'm going to show you an example of how we can see this happening. Here I have an ice cube. It's already starting to melt. Hopefully it will show up so you can see it. All right. If you look at food coloring ice cubes, before they melt, you can see that the top part of the ice cube is more clear, and then the food coloring is in the middle, because when it starts to freeze, it's just the water that's freezing until you get to the middle of the ice cube, and then you find out that, sorry, it's melting everywhere. And then you get to the middle of the ice cube, and then it is forced to freeze. The food coloring is forced to freeze along with the rest of the water. It's that same system that's happening with ice water in the ocean. The salt is being excluded and not frozen into the ice itself. So we just have water with little pockets of ice. Over time, those pockets of brine will actually leak out into the ocean. And it's super cold water. It's surrounded by ice. It's very, very cold, and so will affect things below because it's so cold. But over time, the holes break or crevices form or something, and they will leak out. So as ice gets older, the salt content trapped inside it goes down. And this only happens with salt water, which is very cool. So the ice in the ocean is actually pure water, freshwater ice with little pockets of salt dissolved inside.